Here we are concentrating on the battery performance parameters. We'll see each and every parameters one by one. The first one, battery capacity. The battery capacity, the amount of recharge generated by active materials at the negative electrodes and consumed by a positive electrode is called battery capacity. Basically, during the charge cycle, the electric charge that the battery can supply is clearly at most crucial parameter. The SI unit for this is coulombs. The charge when 1 amp of current flows for 1 second, the capacity for 1 second. The capacity of the battery might be 10 Ah, means it provides 1 amps for 10 hours. Next is the discharge rate. Discharge rate is basically representing how much current can be discharged from the battery. The rate is expressed as Q per hour rate, where Q is the rated battery capacity and H is discharge time in hours. For battery that has a capacity of QTAH and it is discharge over time T. The discharge rate is the current at which the battery is discharged. The rate is expressed in QH as discussed earlier. Next parameter, state of charge. What is state of charge of the battery? State of charge of the battery, or SOC, present capacity of the battery. It is the amount of capacity that remains after discharge from top of the charge condition. Once you have discharged, how much charge is remaining is called as state of charge. Next is state of discharge of the battery. State of discharge of the battery, SOD, means the charge that has been drained from the battery. Depth of discharge. The depth of discharge, represented as DOD, is the percentage of battery capacity to which the battery is basically discharged. There are many other characteristics we'll see one by one. Next parameter is cell and battery voltages. An electric cell has nominal voltage which gives the approximate voltage when the cell is delivering electrical power. The cell can be connected in series to give the overall voltage. The battery is represented as having a fixed voltage E. That voltage at the terminal is a different voltage V. Hence, V is equal to E minus I into R. Next parameter, charge capacity. The electric charge that the battery can supply is clearly a most crucial parameter. The SI unit is coulomb. That means the battery capacity is represented in the form of EH. Energy stored. The energy stored in the battery depends on the amount of energy that can be stored in the form of the charges inside the battery. The SI unit is joules, and this is basically a smaller unit. Energy in WHR, that R, is volt into ampere per hour. Next parameter, specific energy. Specific energy is the amount of electrical energy stored for every kilogram of the battery mass. It has units in Wh per kg. Next, energy density. Energy density is the amount of electrical energy stored per cubic meter of battery volume. It normally has a unit in Wh per meter cube. Next, specific power. Specific power is the amount of power obtained per kilogram of the battery. It is highly variable and rather anomalous quantity. Since the power is given out by the battery depends on far more upon load connected to it than battery itself. Charge efficiency is an ideal word of battery would return to the entire charge put into it, in which case the ampere hour efficiency is 100%. However, no battery gives its charging efficiency is less than 100%. The precise value will vary with different types of the battery, temperature and rate of charge. It will also vary with state of charge. Energy efficiency is another very important parameter and is defined as the ratio of electrical energy supplied by the battery to the amount of electrical energy required to return it to the state before discharge. Self-discharge rate. Most batteries discharge when left unused, and this is known as self-discharge. This is important as it means some battery cannot be left for a longer period without using it or without recharging it. The rate varies with battery type and with other factors such as temperature. Higher temperature generally increases self-discharge. Battery temperature, heating and cooling needs. Although most batteries run at ambient temperature, some runs at higher temperature and needs heating to start them. So this basically decides the efficiency. When choosing the batteries, the designer needs to be aware of the battery temperature, heating and cooling needs, and has to take that into consideration during the vehicle design process. Next is battery life and number of cycles. Most rechargeable batteries will only undergo a few hundred deep cycles to 20% of the battery charge. However, the exact number depends on the battery type and also on the details of the battery design, on how the battery is used. Battery capacity, the amount of e-charge generated by the active material, negative electrode and consumed by positive electrode is called battery capacity. These are the important parameters for the battery. Going into technical characteristics, the battery is the simplest form and can be represented by an internal voltage or the EV, and we can connect it in series with the resistance, so the output is in the form of potential. The internal voltage appears at the battery terminal as an open circuit voltage when there is no load connected to the battery, and when the load is connected to the battery, the potential is fetched as we have kept the circuit in the closed loop. The internal storage or open circuit voltage depends on state of charge of the battery. It depends on state of charge, temperature, past discharge, or discharge history we can call it as, or we can also call it as memory effect among the other factors. The open circuit voltage characteristics is very vital, which is the deciding factor for the choosing of the battery. Here we have illustrated the battery terminal voltage. You can see over a period of time, okay, the voltage is decreasing. So here we have a battery is OD measurement. So battery pack we have the drivetrain, how the terminals of the batteries are connected and how it is given to the SOD is being illustrated here. So this is what we had planned for this particular session on module 3. We have seen important performance parameters and how the analysis of the battery can be done in this particular session. Hope this puts or throws important light on the important parameters need to be considered while selecting a battery for the application Here, the application is basically to provide the energy needed for propelling the electric vehicles. So, depending on our requirement, we can choose the battery type.